Okay, so this video is on exponential equations within indices. Okay, so an exponent is just a power. So 2 to the power 9, the exponent there is the 9. Okay, so that's all an exponent is. Now, in the context of indices, when you have an equation involving a variable in that power, so something like 4 to the power of 2x plus 1. So when you have a variable up there, so the x in this case, we end up and it's set to something else like 2 to the power 3 or something, we call that an exponential equation because there are exponents involved on both sides and at least one of them has a variable. Okay, so that's another example there. So that's what we're talking about. So now what do we need to do with them? Well, we need to simplify them and solve. So the rules are as follows, and I went through these in the class. So the first thing you try and do is rewrite the numbers, and when I talk about the numbers here, I mean, let me just highlight them here. In this example, I mean the 3 and the 2, the 9, sorry. So I'm talking about the bases. So they're the base numbers. They're the bases on which powers are applied to. Okay, so we need to bring them to the same base if we can. Secondly, then we want to write both sides, so the left hand side and the right hand side, as one power of the same number or the same base. And we should use the laws of indices to help us do that. Okay, so we'll talk about that in a second. The entire chapter covered several of those, and we've done a few more in class, including the negative ones and the fractional ones. So once we have that done, then it's simplified to the point that we can just take the powers and solve them. So again, that will make a bit more sense when we go through an example here. Okay, so the worked example here. Now, all of the rules that we care about for this, the indices rules are on page 21 of the log tables. And for any test you're given, it's not expected that you know these off by heart, but it's expected that you know how to apply them. So that's what you do need to know. Okay, so we'll talk about these as we're going through this. So I've got this exponential equation here. 9 to the power of x plus 1 is equal to 1 all over 27. Okay, so the first rule, just going back to that, is to rewrite the numbers so that the bases are the same. Okay, so let's have a look at these two numbers and see what makes sense. Well, first thing I'm looking at is I've got a 27 here, and I know that uh, 3 by 3 by 3, or 3 cubed, is 27. Okay, so I'll just leave it like that for a second. So that's equivalent to 1 over 27. What do I know about the 9? Well, I know that 9 is 3 squared. So if I put that there and then power it by the x plus 1, so in other words, leave it as is, that's the same as what I've written up there. It means exactly the same thing. So this part here will just turn into 1 over 3 to the power of 3, because that's what it is, okay? Now, what we need to do then, so we brought them to the same base. They're both bases of 3 now, but they're still not simplified enough for us. So I'll just do the right hand one first. So have a look at your rules here now and see, does anything look similar to this one here, 1 over 3 to the power of 3. So this doesn't, this doesn't, this doesn't, but this does here. Okay, so 1 over a to the power of p is the same as saying a to the power of minus p. Okay, so that's when we were talking about the reciprocal there. So in other words, 3 to the power of minus 3 is the right thing to put in here. That's equivalent to this fifth rule here, okay? So that's that part, fully simplified to the base 3. Now, have a look at this. So it's 3 to the power of 2, and then outside of that, it's to the power of x plus 2. Well, the third rule here, this one, that's what that does, right? So a to the power of p, and then outside of all that, there's a to the p, there's a to the power of q. And what you do with the two of them is you do p by q. Okay, so in that case, what I need to do here is 3 to the power of 2 multiplied by x plus 1. Okay, so let's just do that. So 3 to the power of 2x plus 2 is equal to 3 to the power of minus 3. Okay, so that's now fully simplified on both sides. And what you can see here is that the two bases are the same. So in effect, they're redundant, okay, because it's only these two things that are changeable here. So that's what we use for our equation. So I take the 2x plus 2 and I make it equal to minus 3. And then I do normal, regular, linear equation solving. So 2x, so I subtract 2 from both sides, so that's going to be minus 3 minus 2. So that's going to be 2x equals minus 5. And then I simply divide by 2 to bring x by itself. So my answer is going to be 2 to the power minus, sorry, my answer is going to be x is equal to minus 5 over 2. So let's verify that that's right. So my first starting point was that 9 to the power of x plus 1 was 1 over 27. So if I say 9 to the power of, now I need to get this big one here now, 5 over 2 plus 1. Oops, wrong place there. Plus 1. If I have everything right, the answer to this should be 1 over 27. And you can see that it is. Okay, so I verified that this is actually the right answer. So that's what you need to do, okay? So work out that the base, bring it to a common base, 3 in this case. Simplify using the laws of indices, which you were given. You just need to work out which is the right one. And then when everything is simplified sufficiently, set the two equation pieces, the two powers, put them in an equation and solve for the variable. Right, so we'll do some more now. That's a start. Okay, the next one. Right, so I've got 2 to the power 3x plus 1 all over 2 to the power of x plus 2 is equal to 32. So again, my first thing that I want to do is bring everything to the same base. So you'll see here that the only one that isn't the same base at the moment is this one here. Okay, that isn't 2. The other two are 2 already. So let's sort that one out first. So I'm going to just rewrite this line. 3x plus 1 all over 2 to the power of x plus 2 is equal to. Now this one is a multiple of 2, but I can also say it's 2 to the power of 2 to the power 5 or 2 to the power 6. So 2 by 2 is 4, by 2 is 8, by 2 is 16, so it's 2 to the power 5. Okay, so I can rewrite like that. Okay. So sort that out. So now I've brought everything to the same base. So now I need to find the next step, which is to apply at least one or more of the laws of indices to make this simpler for me. Now, so let's have a look at the left-hand side. So I've got something over something else. So there's only two of those that might work for us. There's that one and there's that one. Now that one is very focused on fraction stuff, but this one isn't. This is a division style item where both things have a power of their own. So if the bases are the same, and they are 2 and 2, so it's a to the power p divided by a to the power q, you just subtract one from the other. So for me then, I'm going to use that rule there, and this is going to turn into 2 to the power of 3 x plus 1 minus the other one, x plus 2, okay, plus 2, and that will be equal to 2 to the power 5. Okay, so let's just do this here separately, make sure we don't make a mistake. So I'm subtracting one of these from the other one. Okay, so I'm going to get 2x here, and I'm going to get 2 take away 1 is minus 1. So I'd be left with 2 to the power of 2x minus 1 is equal to 2 to the power of 5. Okay, so I've got two bases that are the same, so I can just merely bring down the powers and set them equal to each other and solve the equation. So that's 2x minus 1 is equal to 5. 2x is equal to 5 plus 1. So 2x is equal to 6. Therefore, x should be equal to 6 divided by 2, which is 3. So we write that there. X is equal to 3. Now let's verify that it's right. So 3x, so that's going to be 3 3's plus 1. That's 2 to the power of 3. So let's just write the whole thing, and this part is 3 plus 2. Okay. So this is going to be 3 3's is 9 plus 1 is 10. So that's 2 to the power of 10. And this one is 3 plus 2 is 5. So that's 2 to the power of 5. When I work those out, I will get 2 to the power of 5, and that is equal to 32. Okay, so that part there is just verification. So I'll take that out. But I verified that the left-hand side is equal to the right-hand side when I plugged in the value of 3. Okay, so that's that one solved. So again, I used this particular law of indices here, the division one, to help me simplify it to the point that I could turn things into an equation. So that's the approach. Okay, we'll do one more. Right, so there's 2 on this page, so let's see. So in fact, this one is an easy one because we have bases that are already the same. So when I'm in that situation, I can merely bring down my 2 powers. So 2x is equal to 10. So all I need to do here is divide both sides by 2, so x is going to be 5. And to verify it, let's just verify it to make sure it's right. So 5 to the power of 2 5's is equal to 5 to the power of 10. Well, we know that 2 5's is 10, so 5 10 is equal to the power of 5 to the power of 10. Okay, so we verified that that's right. The next one is 2 to the power of x is equal to 8. So the bases are different, so I need to make them the same. So 2 to the power of x is equal to 2 cubed is what that is. So here you see I now have the bases are the same. So it's simply x is equal to 2. Okay, and if I plug the 2 back in, sorry, x is equal to 3, I beg your pardon. And let me write that. X is equal to 3. And when I substitute that back in, that's what I get. I get back to 8. So the verification is easy in that case. So let's just do a couple of more to get a feel for them. So they can be quite easy, and some of them are a bit more involved. So let's look at these 2. So 9 to the power of x plus 1 is equal to 81. Now, you can logically think about this as well, right? You kind of know that 9 multiplied by 9 is 81. So you should be expecting that this is going to turn into 2. But let's go through the process anyway. But that would logically tell me that x should be 1 in this case, okay? But let's just go through the process anyway, nevertheless. So this can be set to 9 squared because that will make the base the same as the other one, and this will be 9x plus 1. Okay, so I just made the bases the same. Now that they're the same, I can just say x plus 1 is equal to 2, and no surprises, x is equal to 2 minus 1, which is 1. Alright, so that one, you could see it visually very quickly that the answer was going to be 1. Let's have a look at this one. So again, the bases are the same. You know that both of them end up having to be 7. So this is going to be, you'll see very quickly that this is going to be 3. And that's all you have to do here, right? Because the bases are the same. So just bring down your power is equal to 7. 2x is equal to 7 minus 1, which means it's equal to 6. So x is going to be 3. Okay, so they were handy. You will get some handy ones, but there are ones that are more complicated as well. We'll do these last 2 now. So we've got ones that are same base, so all I have to do is 3x minus 1 is equal to 5. Okay, so 3x is equal to 5. Then add 1 to both sides, plus 1. So 3x is equal to 6, therefore x is equal to 2. And I can verify that by plugging the 2 back in there. So 3 2 is a 6, minus 1 is 5, so that will make that equal. This one then though, I need to do something different, so I'll just continue with this piece of it. That's fine. But this one must change the base. I want to bring it to a base of 2 to make it the same as the one on the left hand side, so that'll be 2 to the power of 4. And then you're left with a simple equation as well to sort out. So x minus 1 is 4, therefore x is equal to 4 plus 1, therefore x is equal to 5. So 2 to the power of 5 minus 1 is 2 to the power of 4, which brings me back to 16. So I verified it. Okay, so that's the gist of these. We'll do a couple of more complicated ones in the last class before the review. But if you've managed to follow that, so the last few there, I didn't have to use these laws of indices because things were already fairly well structured for me. But generally speaking, you'll have to use one of them. This one is very common, for example, where you have something to the power and then another power to outside of that. So look out for that one. But we'll do a couple of more before the review and go back over factorization if that's what you want to do for the last class before we do the review. All right, so I'll leave it there. Cheers.